Hello, so today I'm going to demonstrate on how to solve equations that have multiple angles, half angles, or double angles. So one of the first examples that we can look at is, what if we had the following expression? So let's say that we had 2 cosine of theta divided by 2 is equal to 1, 1. And let's say that we want to solve this equation. So most of the time we want to solve for when the interval is bounded from, let's say, 0 to 2 pi, but then other times we want to look for what we call all solutions. So when we look for all solutions, that means that we're talking about multiple rotations. So let's go ahead and try to solve this equation. So looking at Looking at 2 cosine theta over 2 equals to 1, we know that this is just going to become cosine of theta over 2 equals to 1. Now, let's say that, for example, and that's over 2. Let's say that, for example, that we want to know where is that equal to 1/2 from 0 to 2 pi. Well, we know that, for example, that the angle measure that gives us a half, that's going to be not only in the first quadrant, but it's also going to be in the second quadrant. Okay, so now the angle measure that we have for the first one is theta over 2 is equal to, well, that's going to be pi over 3. So we have pi over 3. And we have also that theta over 2 would have to equal to, well, we have that that's going to be in the fourth quadrant, since we have that it's positive over here and over here. So that's going to be, let's see, so 3, that should be 5 pi over 3. Okay, so looking at this, we know that we just need to multiply by 2 on both sides for each of these. Now, notice that when we multiply by 2, we get theta equals to 2 pi over 3. But we're going to notice something interesting about this one. This one's going to give us that this is going to be that theta is equal to 10 pi over 3. Now, unfortunately, that's giving us beyond the bound. So we have that that this is going to be outside of the bound of 0 to 2 pi. So, for instance, I know that this is going to be 2 pi, and then the remainder is going to be 4 pi over 3. So this is actually outside of the bound of from 0 to 2 pi. Now, what that means is that the only answer that satisfies from 0 to 2 pi is 2 pi over 3. So we'll just say that that's going to give us that this is going to be just 2 pi over 3. So that solves the first part from 0 to 2 pi. But let's say that, for example, that we want to solve for all solutions. Now, if we try to solve for all solutions, then in that case, the only solution that we'll have within the first rotation, that is the 2 pi over 3. So looking at the period of the function, we know that that's going to be 2 pi divided by 1/2. So this gives us that the period is 4 pi. So what this tells us is that the angle, or the solution for all, is going to be 2 pi plus 4 n pi. Not 2 pi, 2 pi over 3. So this is going to be our solution for the all solutions, because we have that it's going to reoccur for every 4 n pi rotations. Okay, so next, what we can look at, for example, is that what if we have an angle measure that is a double angle? So let's say that you have okay, so suppose that you have the square root of 2, and you have cosine of 2 theta is equal to 1. Well, in this case, let's say, for example, that we just want to know for all solutions. So we'll just say that this is going to be solved for all solutions. Well, as we go ahead and we try to solve this equation, we have that that's going to be, okay, so we have the root 2 cosine theta, that's going to be 2 theta. So we have cosine theta. Now, this is going to be equal to 1, of course, but we're going to divide by the square root of 2. And then that's going to tell us that we have that cosine, and that should be a 2, by the way, yeah. And that was the whole point of erasing that. So we have cosine 2 theta equals to the square root of 2 over over 2. Now, the way of which that we're going to solve this is that we're just going to say that, well, we know that the angles that give us root 2 over 2, if we think about it like this, that's going to be 1, 1, root 2, and that's going to be 45 degrees, or, pi over 4. So that means that the 2 theta, it has to equal to pi over 4. And it has to equal to 11, no, it should be 7 pi over 4, yeah. Now, note that if we go ahead and we solve this, then that's going to give us that we get that theta is equal to pi over also have that that's going to be 7 pi over 8. Now, one thing to note is that you have that 2 theta is your is only just half of a rotation. So what that means is that we have that there is more rotations that do occur. So in actuality, we have only accounted for just like half of them. So what that means is that we can go ahead and just say, well, we have that's going to reoccur, the 2 theta, and we have that's going to be pi over 4 plus 2 pi. But if we go ahead and we divide by 2, then that's going to give you theta equals to pi over 8 plus pi. But that's going to be 9 pi over 8. And then if we do another computation of the same thing, then we're going to find that the next one is going to be the next theta value is going to be that 2 theta equals to 7 pi over 8 plus 2 pi, but this is going to be equal to, not 7 pi over 8, 7 pi over 4. This is going to be equal to 7 pi over 8, and that's plus pi. But that gives you, let's see, 8, 15 pi over 8. Now notice that we are within bound of the unit circle of the from 0 to 2 pi. Now what we can do is figure out like what are the solutions for this example. So it should be noted that one rotation, or one period for that matter, for the double angle is pi. Now let me just check that we didn't overdo our solutions, because if we have, yeah, I think we did. So I think that this will account for the one rotation, so the pi, and this will account for the next rotation, another pi. So actually these are a little bit of extra solutions. So what we should have done was just take the 2 solutions of pi over 8 and just add n pi. Yeah, because I just noticed that if we go ahead and we include the pi plus that gives you the same thing. That's the one rotation. And then we have that the next one would be 7 pi over 8. And that's going to be plus another rotation of the pi. But we'll just put an n there. Now n is just an integer. Okay. So that, I guess that tells me that we really should just look at what the one period is first. So that way we don't overdo it in terms of the solutions. Now, the next example that I want to look at is whenever I have an equation that involves a double angle. So that one was a double angle too, but let's say that you have sine 2 theta is equal to cosine of theta. So if I want to solve this, and let's just say that we want to find also all solutions, maybe. Actually, we'll just go ahead and say that we'll restrict it from 0 to 2 pi. Okay, so if we go and we just try to solve this, we need to say that we have sine 2 theta equals to cosine of theta. but this gives us that 2 or sine 2 theta is 2 sine theta cosine of theta equals to cosine of theta. So we just subtract and we get the following. We get that 2 sine theta cosine theta minus cosine theta equals to 0. So this gives us that you have cosine of theta multiplied by 2 sine theta minus 1 equals to 0. So now we can actually go ahead and furthermore solve this by saying that cosine of theta is equal to 0, or you have that 2 sine theta minus 1 is equal to 0. So, well, from here you have that theta must equal to pi over 2, and then you have that it's going to be also 3 pi over 2, and that's just for the this cosine theta. But you have that with this one, you have that this one is sine theta equals to positive 1/2. So that's going to be where you have 30 degrees as a reference angle, so it's positive. So we have, not 30, but pi over 6, right? Okay, so pi over 6. And then you have that the next angle measure would be, let's see, 30 degrees, so that should be 11 pi over 6. Okay, so what this does is it tells us that we have that this is where the equation will equal to 0. So if we plug in pi over 6, you get sine pi over 3, and then that should give you what you want. So we don't really have to account for any rotations because we're just saying that it's from 0 to 2 pi. Whereas like if it was unrestricted, then it would be a little bit different if it was unrestricted. So we have that our solutions are pi over 2, 3 pi over 2, pi over 6, and 11 pi over 6. And that's it. So we have that you can find equations that have multiple things, and if anything, it all just comes back to either using the unit circle or maybe even a calculator. For instance, you can graph each of these and then just try to see like where they intersect, for example. But you know, that's gonna require just changing, like for instance, like the window. Like if you go to here, and you got to make sure that your mode is in radians, for instance, and just put that you can say sine 2 theta or 2x, and then just put cosine of x, and then just go to let's go to graph and see what we get. Okay, so let me do zoom, and we'll just do standard. So you can find where they intersect, for instance, but it's not going to tell you like exact values. It's just going to say that, you know, that it's going to be in its approximation. So see like how you have 0.5235988. Well, that's probably going to be like the first intersection, because you can see that there's happening multiple times along the x-axis. So that's just to give you an idea, like, you know, how can you use the technology. So yeah, you can see that there's one right there, and there's one right there. Okay, so just really go ahead and more or less practice how you can find some of these by hand, if anything. If not, then yeah, you can use things like the calculator or even like Desmos.